Hello everyone, welcome to Unit 1, Day 14. I don't know why I didn't edit that, that's Day 14. We're going to be talking about measures of center. Alright, so our goals today, we're going to learn how to calculate the most common measures of center, known as the mean, median, and the mode. We're going to learn how to find those measures of center using technology, and we're going to learn the notation associated with each measure for a population and a sample. Alright, so let's dive right into it here. So we've got some students that want to know how consistent a tennis ball launcher is. So these students fired 30 tennis balls from a tennis ball launcher and recorded the distance in feet that each ball traveled. So they fired a tennis ball and it went 32 feet, and then 28 feet, and then 34 feet, and they repeated this 30 times and collected that measurement each time, right? So we have all of the data for us right here. Okay. And we're going to calculate these measures of center based on that data. Right. So the first measure of center we're going to learn about today is called the mean. Now, if you've never had any statistical training before, this word is more commonly recognized as the average. Okay, you've probably calculated an average before, but it's more for people who haven't done statistics. They recognize this word more than they would the mean, right? So the mean represents the average distance that the ball traveled in their experiment, but in statistics land we say, what is the mean distance that a tennis ball traveled in your experiment? All right. So the way to understand the mean is to imagine constructing a histogram, right? So we've constructed histograms in previous lessons. So imagine constructing that histogram on a thick piece of cardboard and then cutting out that histogram. Then imagine trying to balance that histogram on the tip of your finger. All right. The balance point, where you move that histogram so that your finger is perfectly placed so that it balances without falling, that balance point is where the mean would be. Alright, so that's how I like to think of the mean. It's the balancing point of the histogram, and it is used to describe the center of the data. Alright, so we're going to learn now how to find the mean for this data set. It's actually really easy. Like I said, most of you have probably done this before, but you would simply take all the data values and you would add them up and divide by the number of pieces of data that you have. Alright, so in this case, you would add up the numbers and divide by 30, because there's 30 tennis balls that were fired. Now, the formal formula looks like this. All right, so we would say sigma x. This weird-looking symbol right here is the Greek letter sigma. So this means sigma x over n. All right, and this weird symbol that we see, this Greek letter means sum. Okay, and remember, sum means to add. Right, so we're going to add the data, right? X represents the data values, and then we're going to divide by the sample size, and that's what n represents. That is our sample size. Okay, and when we do this calculation, the number that comes out is the mean, and it is represented by this symbol. We say x bar, and this is the sample mean. Okay, so there are two different means out there. There is a sample mean and there is a population mean. So when we are working with a sample of data, like we are up here, right, we use x bar. This is our sample mean. If we happen to have the entire population, if we're able to get the data for an entire population, then we would use this symbol instead. And this is the Greek letter mu, it's a lowercase mu, and this represents the population mean. Okay, and this is important. You're going to want to make sure that you pay attention to notation. So if I gave you a problem and I said calculate x bar versus calculating mu, it could potentially be two different calculations, because x is going to refer to a sample of the data, whereas mu is going to refer to all of the data for all individuals in the population. All right, so the calculation is slightly different. All right, now I'm going to show you how to actually find this rather than adding these up by hand. This is actually a perfect task for a piece of technology to do for us. So we're going to use the TI-84 to help us find the population mean. All right, so let's do that real quick. I'm going to turn on my calculator, and we're going to start by hitting the stat button. and you'll see option 1 here says edit. That's exactly what we want, so we want to go to edit, and you'll notice that we're in that list menu again. Okay, so I'm going to enter in all of my data here into list 1. If you've already got stuff in your list, I put some data over here in list 2. I'm going to show you how to clear that out real quick. So you're going to want to go up until you see the list that you want to clear highlighted, just like this, and then you're going to hit the clear button and then click down. And when you do that, it'll get rid of everything in that list in just a couple button pushes, rather than going through and deleting each individual piece of data. All right, so go ahead and take a couple minutes and you can enter in the data that we have here. You should have 30 pieces of data when you're all done. Once you're done entering in the data, you can actually hit second mode. That'll quit you out, and it automatically saves, so you don't have to worry about clicking save anywhere or anything like that. It's automatically stored in there. And then what we're going to do is we're going to go back to Stat, and we're going to go over to the Calc menu. Okay, and you'll notice that first option says 1-bar stats. We saw this in some previous lessons. This 1-bar stats is extremely important. You're probably going to use it hundreds of times throughout this class. All right, so select option 1. Okay, make sure you have the right list here. If you put your data into L2 or list 2, change it to list 2. If you put it into list 3, change it to list 3. Mine is in list 1, so mine is good. And I'm going to go down to calculate. Right, and you'll notice the very first number. Right, you'll see our X bar. That's the symbol that we just learned about. This is our mean. Right, and the calculator calculated that for us right away. So I'm going to come over here. I'm going to say X bar equals 34.966 repeating. Okay, that keeps on repeating. You'll also notice some other numbers over here. So you see that sigma x, right? So that would be the top of our fraction. So this is all of our data values added up. You'll also see the n right here. It says n equals 30. That was our sample size. Right, so you see it calculates a lot of things for us that might be handy later on. 1-bar stats is a very powerful feature of our calculator. All right, so we're just going to say, hey, we calculated this using 1-bar stats. And this is how I would expect you to find the mean all the time. Okay, I'm never going to expect you to add this stuff up by hand. That's just ridiculous. All right, so there we go. So we're using 1-bar stats to find that for us. And one more thing I just want you to put in your notes. We're going to talk about this more tomorrow. This is not resistant. Okay, I just want this here for a reference. You're going to come back and try and remember which measures of center are resistant or not. So just put that over here for your reference for later on. The mean is not resistant, and we will talk about what that means tomorrow. All right, so let's move on to our next measure of center. This one is called the median. And you're probably thinking, well, Mr. Rowan, we know the median because we learned about this when we talked about measures of position, and you would actually be right. It is the same exact thing. It's a little bit different. It is a measure of center, but it is the physical middle. It's not necessarily a balance point. It's just the physical middle of our data. All right, so if you can imagine constructing that same histogram on another thick piece of cardboard and cutting it out, and then you started painting it, right? So as you paint from left to right, the median would be the place where you use half of the total paint. Okay, it is the halfway point. Another way to think about it is if you took all of your data and you ordered it, right, into a big list, and then you karate chopped it perfectly in half so that half the data ended up on the left and half the data ended up on the right, that is where the median would be. All right, so this is another way to measure what we call the center. Okay, and this is the important word here, the center of the data set. All right, so some of the symbols that you will see out there for the median, some of them use a capital M, some will say MDN, just like that, and then this symbol here, X with a tilde. All right, so these are all symbols for the mean. I'm sorry, for the median. There you go. All right, there are no differentiating symbols for a population or a sample, so there's no population symbols like there was for the mean. It's only for the mean. All right, so the way that we find it, if you recall from previous lessons, the first thing we have to do is we have to order the data. Okay, so you got to get that data in order from least to greatest. and then you just find the physical middle. Okay, and there were a couple of different scenarios that we talked about in the previous lessons for finding that physical middle. Sometimes it had an even number of data or an odd number of data. So depending on whether or not it was even or odd, we might have to take the two middle numbers and average them, or it could just be one number that is the actual middle, depending on the even or odd number of data that might exist. Okay, but we can find the median really quick using one var stats in our calculator. So if I just scroll down over here, you'll see it gives us the median here at 35. So I can say x tilde, or the median, equals 35. All right, and again, use one var stats. That is the quickest way to find your median. All right. Couple of notes about the median, a couple of interesting things. So we can say if, and this is an if-then statement, so we're going to say if the mean equals the median, then the data must be symmetric. Okay, so that's a very useful piece of information to have, because I might just give you a set of data and ask you to tell me about the shape of the data. And this is a really quick way. If you run a one var stats on a set of data, you can quickly go to one var stats, look at the mean, look at the median, and if they're close to each other, they don't have to be exactly equal, but if they're somewhat close, you can say that it's roughly symmetric. All right, and so it's a quick way to judge the shape of the data. Now, do not assume that just because something is symmetric that it is bell-shaped or normal, because a uniform distribution is also symmetric. So this just tells you that it has symmetry. It doesn't tell you that it's normal. All right. The other thing that you should know about the median is that it is resistant. Okay, this one is resistant, and the mean is not. All right. The last measure of center that we're going to talk about is the mode. So sometimes we use the center of a data set to describe a typical value, and sometimes the most typical value might be the number in the data set that is reported most often. So we're looking for repeating numbers to find a mode. All right, so if you look at our data that we're dealing with for ours, I'm going to show you how to find that quickly here on the calculator. You cannot use one var stats to find the mode, but you can use the sorting feature to find it pretty quickly. All right, so I'm going to go to stat. I'm going to go to this option here that says sort A, and I'm going to tell it to sort list 1. You might remember this from a previous lesson, but it's good to see it again. Once you hit enter there, it'll say done, and then you can go back to your data, and you'll notice that all of my data in list 1 has been sorted. And then I can scroll down and I can look for repeating values. So I can see 33 repeats twice, but then if I keep going, you'll see 34 repeats 1, 2, 3, 4 times, and then if I keep going, 35 repeats 1, 2, 3, 4, 5 times, and then 36 repeats 3 times, 37 4 times, 39 twice, right? So it's the number that repeats most often, and if you keep going through this, you're going to find that 35 is the one that repeats the most, right? So we found out that 35 repeats the most, right? So the mode is 35, okay? And we can actually just put an equal sign there, right? Mode is equal to 35. All right, there are no special symbols for the mode, right? No symbols for the mode. You just write the word mode. That's what most people do. If you Google mode and you're able to find a symbol, let me know. I'll gladly use it, all right? But as far as I know, there's no symbols that represent it. You cannot use one var stats on this one. Okay, but what I would recommend is that you order the data and look for those repeating values. That is the easiest way to find it. Okay, this one is resistant. So it is resistant, and that's really all there is to say about the mode. Another thing that we could note about it is that it has the ability to be bimodal or multimodal or no mode, right? So if a data set has no mode, then that means there's no repeating values. Okay, so that is actually a fault of the mode, right? Because you have to find a measure of center, and if you're going to rely on the mode, there's a possibility that one doesn't exist, so that's not a good thing. Okay, so there's a possibility of having no mode, and then there's also this possibility of being bimodal or multimodal. So I'll show you what that means here in this particular data set. So we have the Old Faithful eruption times, and you'll notice as I go through the data that 92 repeats twice, so does 95, and so does 98. So we have three different numbers that repeat twice each, and so there's no one number that repeats the most. So this is one that has three modes. So we would say the mode equals 92, 95, and 98. And so we would call this multimodal. Alright, and if it were bimodal, then we would have two numbers. Anything past two, we just say multimodal. Alright, and just one more note here, the mode is not often used primarily for the reasons that we're seeing here, is that it's not really a consistent way to find a singular measure of the center. You could end up with several different measures or no measures at all. So it's not typically used with numerical data, but it can be used for nominal type measurements such as names and labels, categories, pets, things like that, is where you will see the mode used the most. All right, and again, can't use one-var stats, but you can use that sort feature on your calculator to help you find those repeating values. Alright guys, that's it for today's lesson. Give the practice problems a try. Tomorrow we'll talk about resistance. Have a great day.